All right, folks, it's back in action here. In this video, we are going to go through finding vertical or horizontal and oblique asymptotes. And I just want to call your attention real quick to the fact that our graphs for rational functions are going to look very different than many other things that we've graphed. We're very accustomed to them looking like this, but actually rational functions come in a wide range of graphs, as you can see as demonstrated here. The other thing is that we need to get a better understanding of what asymptotes are. So asymptotes are simply boundaries that our graph is going to approach, okay? So it's always going to approach them, but there are actually some types of asymptotes that the graph can actually cross, okay? So as our x values are going to go to positive and negative infinity, so out here, okay, so as we move farther and farther out here, our graph is actually going to approach either these horizontal or oblique asymptotes. You'll only have one or the other. So we can see as we go out here to the left and the right that it's getting close to this horizontal. I can see as I'm going left and right here, my graph is getting closer and closer to this slanted line. That's going to be called an oblique, okay? Functions can cross these horizontal and oblique asymptotes, and we can see that actually right here, okay? We have a horizontal asymptote right here, and we can see our graph is actually crossing it right there on that x-axis. Now, as our y values get bigger and bigger or smaller and smaller as the top and the bottom, they're actually going to start to approach our vertical asymptotes. Functions can't cross the vertical asymptotes, however, though, because our functions are actually undefined at those values. That's what's going to create these vertical asymptotes. So it's important to kind of just keep that in mind as we start to work through this and not be surprised when we start to see graphs crossing horizontal and obliques, but never the verticals. Now, before I get into these new rules, it's really important to remind you of this review idea because students forget this a lot, okay? If our rational function is in this form that we've been working with since our Algebra 2 days, we can actually visualize a really quick graph of this using our transformation. So it's been shifted left 4 and up 1. So that means that our asymptotes are going to actually look like this, -4 and up 1. So without doing a whole bunch of work or using any of our new stuff, we can see that we have a horizontal asymptote here at a y equals 1, and we have a vertical asymptote here at an x equals -4. So that's just a really important idea to keep in mind. Now, when our rational function is actually written as a single expression, okay? So we've got this single expression, so it's just one fraction. It's going to be one polynomial divided by another polynomial. We're going to have some new rules that we're going to be able to follow, okay? Now, you can only have a horizontal or an oblique. You cannot have horizontal and oblique, and sometimes you might not actually end up with it's possible for us to have, like no oblique. Sometimes the oblique will be a line and sometimes it'll be a horizontal. And not all of our rational functions will even have vertical asymptotes. So don't assume that every rational function is going to have something of everything. But we've got these horizontal and obliques. Obliques are going to come in two different forms. It'll either be a line, this is going to be our main focus, or we're going to have things that are not going to be lines. What you can do after this video, if you're a little confused how this can happen, is you can type this function into Desmos and get an idea what it's going to look like. But for right now, I just kind of want to go through how these rules are going to work. Horizontal asymptotes, okay, so if you have a horizontal asymptote, what we're going to always be looking at is the degrees, okay? So we're going to be looking at the degree of the numerators and denominators, okay? So those degrees, remember degree is the highest exponent. So if the degree in the numerator, for example, let's look down here. We're going to call this one a bob. So if the degree in this numerator is smaller than the denominator, or a bob, we're going to call this a bigger on the bottom, and you might want to write that down, bigger on the bottom. So we can see here that my degree on the bottom is bigger, so I'm bigger on the bottom. Then you don't have any other work to do. Your horizontal asymptote is automatically y equals 0. Now, the reason why that is that if we try to do some long division on this, we're going to quickly see that our long division doesn't actually go anywhere for us, okay? We're going to end up with this 2x squared minus 1, and we're trying to divide it into this 12x plus 1. But what we learned from our long division days in Algebra 2 is that if we tried to do that, we would say 12x divided by 2x squared. We'd say, oh, well, this isn't going to go anywhere because there's nothing to put up here. We already have ourselves a fraction, so we would just stop. That's why this, when we have this bigger on the bottom, it's automatically y equals 0. Now, our next possibility is what we call a SAM, or same, okay? So now we're looking at these two degrees. The degree on the bottom and the degree on the numerator are the same. So we're going to call this a SAM. Okay, when we have that, what we're going to do is we're going to grab the two coefficients, and we're going to write those as a fraction. So y equals 12 over 2, which of course reduces, and we get a horizontal asymptote of y equals 6. And as I mentioned about this problem over here, if you type this or this into Desmos, you'll see that you have on this bob, you have an asymptote. It's going to approach that y equals 0. On this one, you'll see that you have an asymptote of y equals 6, and it's approaching that. Now, if we do this long division, if I try to jump into this one, it's going to end pretty quickly. I'm going to get this 2x squared minus 1, and I'm going to have this 12x squared plus 1. And as soon as I start this long division, I'm going to have this 12x squared divided by 2x squared, and that's just going to immediately give me a 6. This 6 is the same 6 that we're getting there. So we don't need to actually do this long division each time. I'm just showing it here for you so that you can understand where this 6 is coming from. I want you to be using this rule for the SAMs, okay? Now, when we get into things that are obliques, and we're going to call these bots, bigger on the top. So we have bigger on the bottom, and we have bigger on the top. If we have a bigger on the top, then it's going to be an oblique. It's no horizontal anymore. It's now oblique. It's going to be slanted in some fashion. If it's bigger in the top and it's by exactly 1, the degree in the top is exactly 1 more, then our asymptote is going to be a nice line. Okay, so we can do that long division, and this time we're going to have to do long division. Okay, you will not be able to get your oblique asymptotes without doing long division. So I'm going to have my 12x cubed, and I'm going to go ahead, I'm going to space this out, and I'm going to give my plus 1 over here. I'm not going to bother to write all those zeros. I could, but it's not really that necessary. So if I take 12x cubed divided by 2x squared, and you might need to write that out to the side, but if you take 12x cubed divided by 2x squared, you're going to get 6x, okay? Now, if I take that 6x, and now I'm going to distribute, so 6x times 2x squared is going to give me 12x cubed, that's just what I wanted, and then 6x times the negative 1 is going to give me a minus 6x. Now, long division says that we need to do some subtraction here, so I'm going to flip these signs, and I'm going to add these. So that goes away, and I get a 6x. Now, at this point, we're essentially back to where we were here. Our 6x and our 2x squared says we're just going to stop. So this feels weird to a lot of students, but we're just going to throw out this remainder. We're done. Whatever is sitting up here is going to be our asymptote. So our line is going to be the line y equals 6x. If you want to write in that y-intercept of 0, you can do that if you want, but this is going to be our asymptote. Now, if we have a bot, a bigger on the top, and it's by more than 1, okay, so if we have more than 1, then we could get any variety of types of things, okay? And again, whenever you have an oblique, you have to do long division. You should never need to do long division over here. So I'm going to have my 2x squared again, minus 1, and I'm going to have my 12x to the 4th, and I'm just going to give myself some space here for my plus 1. So 12x to the 4th divided by 2x squared is going to give me 6x squared. So now my asymptote is actually going to be a parabola. It's going to be very strange. So I'm going to multiply this back out again. So I'm going to get 6x squared times 2x squared is going to give me 12x to the fourth. That's what I wanted. 6x squared times the -1 is going to give me a negative 6x squared. I need to subtract again. I like to flip the signs and add. And when I do that, that's going to give me a 6x squared. I'm going to bring the 1 down. Now I can continue my long division. So 6x squared divided by 2x squared is going to be a 3. So I'm going to write plus 3. And 3 times 2x squared, we're going to multiply this back out. Gives me 6x squared. Yay, that's exactly what I wanted. Minus 3. And now I'm going to flip those signs one more time and add, and it cancels again. And now my degree down here is less than here. So again, I just get to stop. We just throw out the remainder. It's not useful for us. So our asymptote turns out to be y equals 6x squared plus 3. And if you type both this equation and this asymptote into Desmos, what you'll see is that the graph is going to approach this asymptote, this parabola, as it moves, as the x values get farther and farther out to positive and negative infinity. So we're going to practice more with these, but the main big ideas I want you to have in your head right now is that you can only have horizontal or oblique. If it's horizontal, you've got quick rules, and if it's oblique, you have to do long division.